Welcome back, everyone, to the Unlock Project podcast. I'm Meryl, your host, and this podcast is brought to you by Greenovate Europe. We are here to talk about the EU-funded Unlock project, which aims to convert chicken feathers into bio-based plastics. In each episode, we explore different aspects of the project, focusing on the contributions of our project partners. Today, we are joined by Eveline Beeckman from Normec OWS, the global leader in biodegradability and compostability testing with over 30 years of experience. Normec OWS plays a crucial role in the Unlock project by testing the biodegradability of keratin-based bioplastics and ensuring they meet environmental standards. We'll discuss today how Normec OWS evaluates the biodegradability and environmental impact of Unlock bioplastics and their role in certifying the materials to international standards. So join us for the episode today. So welcome, Eveline. It's great to have you here today. As a first question, could you start by introducing yourself and explaining Normec OWS roles within the Unlock project?
So hi, my name is Eveline, and I've been working at Normec OWS for almost 5 years now as a study director in biodegradation and composting. So Normec OWS is the global market leader in biodegradability, compostability, and ecotoxicity testing of different types of materials. We also offer a wide range of additional services such as auditing, controlling and sorting of waste from waste inspection, also life cycle assessments and other sustainability studies. We always work according to high quality standards, and we have built up a lot of expertise over the past more than 30 years, and we are recognized by all certification bureaus worldwide in the field of biodegradable or compostable materials. We actively participate in many certification and standardization committees, as well as European projects like Unlock and also international conferences. So within the Unlock project, we are responsible for the biodegradability and compostability testing of the developed materials, and also for the life cycle assessment.
And now looking specifically at the biodegradability testing, can you describe the method Normec OWS uses to assess the biodegradability of the keratin-based bioplastics that are developed in Unlock, and what specific environments do you test these materials in?
So within the project, we actually work in 3 stages. So in the first stage, we perform screening tests, which are mostly disintegration tests in compost and in soil. And this is to help in the selection of the most promising materials. And in this first stage, we also performed a biodegradation test on the treated feathers separately in order to evaluate the impact of the different treatment methods. And then in the second stage, the lead candidates are further tested for biodegradation and disintegration, and also other environments are considered, like home composting or water environments like freshwater or marine environment, to evaluate what will happen to the product in case of accidental spill. And then finally, the developed end products will be evaluated for organic recycling according to the harmonized standard EN 13432 on industrial composting. So this involves both biodegradation and disintegration testing, as well as evaluation of the environmental safety, which is through plant toxicity tests and also the effect on the compost quality. And depending on the final application, also anaerobic digestion or home composting or degradation in other environments can be evaluated. So if you want, I can go into more detail about the different tests. So the 2 main tests that we perform are biodegradation and disintegration tests. So biodegradation is the complete conversion of the material by microorganisms into CO2 and biomass. So this means complete mineralization, while disintegration is the physical breakdown of a material into very small fragments. So both tests can be performed in the different environments like compost and soil, which will be mostly the case for this project, but also freshwater, marine environment, etc. So in a biodegradation test, we add milled sample to the inoculum, which is then the compost or the soil, and we incubate it at a specific temperature. There is also a control reactor taken along and a reference reactor, which contains cellulose, which is the reference material. And then in each reactor, the CO2 production is measured. And from this, we then can then calculate the biodegradation percentage. So samples should always reach 90% absolute or relative biodegradation within a certain time frame, which is depending on the environment. And then in a disintegration test, we actually add the samples in their final form, so the final end product, or for large materials, we can also cut them into smaller pieces. And again, the same principle, they are incubated at a specific temperature, and regularly we visually check the disintegration. And at the end of the test, then we see how much remaining pieces larger than 2 millimeter there are and they are weighed. And then from this, we calculate the disintegration percentage. And again, the criteria is 90% disintegration.
And as a follow-up question, how do keratin-based materials behave differently in terms of biodegradation across various environments like the soil or the compost, as you mentioned?
Biodegradation can indeed vary across the environments because a different environment means different aggressiveness. This is mostly linked with the temperature and the microorganisms that are present. So under industrial composting conditions, the temperature will be quite high and there will be bacteria, fungi, and actinomycetes present. And in the soil, temperature is already much lower, while in freshwater, for example, temperature is still a bit lower and only bacteria will be present, so no fungi or other organisms. So therefore, it is very important to always specify in which environment a product is degradable. And regarding the keratin-based materials, the biodegradation will mostly be quicker under industrial composting conditions, as this is the more aggressive environment. But of course, the final biodegradation of the materials will also highly depend on the polymers that are used. And as I already mentioned, we also have tested the untreated raw feathers and the treated feathers treated by steam explosion separately for biodegradation in soil and in industrial composting. And from these results, it was clear that the treated feathers, so the steam exploded feathers, degraded very quickly. So the treatment had a very positive effect on the biodegradation. And they degraded more quickly in the industrial compost compared to the soil.
Okay, thank you for that explanation. And in terms of environmental impact, how do the bioplastics developed in Unlock compare with traditional usual materials, and what is the added value in terms of biodegradation?
So the goal is, of course, to create products that don't have a negative effect or even a positive effect on the environment. And regarding the end of life, this mainly relates to plastic waste generation. So the use of agricultural products made of conventional plastics produces large amount of plastic waste and can also lead to the accumulation of microplastics in the environment. So with the unlock materials, we want to aim for zero waste generation by creating materials suitable for organic recycling, which can be industrial composting. And furthermore, controlled biodegradation in field can also be an advantage for some applications, meaning that after its useful lifetime, the product will be completely biodegradable in the environment. And by creating biodegradable products, we can also reduce the accumulation of microplastics. And finally, products can also have a positive effect on the environment. The unlock products all contain significant amounts of keratin, which means that if they start degrading in the soil is enriched with nitrogen, and this can increase the crop production.
Okay, and as you mentioned before, Normec OWS is also involved in the certification process of Unlock materials. So could you explain to the listeners the involvement in the certification process and what standards are you aiming to meet?
Yes, so our role in the certification process is mainly to make sure that all necessary tests are performed to meet the criteria of the standards or the certification schemes. So the most important standard for the unlock products is the harmonized standard EN 13432. which I already mentioned before. So the aim is to have all materials industrially compostable, and for some products, also the possibility of applying a label on compostability. So, for example, the seedling logo by European Bioplastics or the OK Compost Industrial logo of TÜV Austria, Belgium. Furthermore, where relevant, we will also evaluate the suitability of organic recycling by anaerobic digestion and the suitability for a home composting, and maybe also obtaining the OK Compost Home logo. And for the mulch film, this is a bit different. The mulch film will be evaluated for biodegradation and environmental safety according to the standard EN 17033, which is a standard on biodegradable mulch films.
Can you explain what does the process look like for obtaining the certifications for these biodegradable and compostable products? And are there any specific challenges or milestones that you need to overcome?
Yes, so to obtain a certification for a product, you have to apply to a certification institute. There are different certification institutes like TUV or DIN, and they all have their own certification schemes. The schemes are based on existing standards that are developed by the standardization committees like CEN or ISO, but they are more practically oriented. So the Certification Institute will assess the test results that are delivered by an independent lab, like we are at Normec OWS, to see if the product is eligible for their label or not. So at Normec OWS, we are actually recognized by all certification institutes in the field of composting and biodegradation. One of the challenges regarding certification is maybe just choosing which certificate to go for, as there are many options. And we do see that in some countries there is a preference towards a certain certificates.
Okay, thank you so much. And finally, as a last question, can you explain how do these certifications influence the development and eventual commercialization of bioplastics within the Unlock project?
So the products within the project have to be developed so that they comply with the certification schemes. So therefore, adaptations are often necessary, and this can be in the materials that are used or in the structure of the product, like the thickness, for example. Regarding commercialization of the products, it's quite clear that certifications shows a proof of concept. It guarantees that certain standards are met, and it also contributes to the green image of the manufacturer and of the consumer. But furthermore, there's also the regulatory aspect. Certificates can be used to demonstrate compliance with the legislation to the authorities. For example, the European Parliament recently adopted the plastic packaging waste regulation, which replaces the plastic packaging waste directive. And this regulation states that certain products like tea bags or fruit stickers, they have to be compostable.
Thank you, Eveline. Thank you for joining us today and sharing these insights about Normec OWS work within the Unlock project. It's been great to learn about the intense process of biodegradable testing and certification of keratin-based bioplastics within Unlock. Thank you so much.
Thank you.